Hello, welcome again. We are solving some questions of theory of machine. The topic is displacement, velocity and acceleration of planar mechanism. Question number 30 and 31 carries a common statement. The statement is a quick return mechanism is shown below. The crank OS is driven at 2 revolutions per second in counterclockwise direction. So this is your quick return mechanism. This is 500 mm and this is OP and this slider is S. This is point Q and this is slider or slider R. Okay. So question number 30 is if quick return ratio is 1:2, then the length of the crank in mm is option A 250, option B 250 root 3, option C 500, option D 500 root 3. Question number 31, the angular speed of PQ in revolution per second when the block R attains maximum speed during forward stroke with slower speed. So question number options are 1 by 3, option B 2 by 3, option C 2 and option D 3. So here suppose this is your as we can see from the diagram, this when point Q is at this location, then R is slightly in backward position. So when it reaches at extreme forward of its travel, because it will oscillate. Okay, so when it reaches extreme forward, so then the slider will be at extreme backward position. Okay, so now this is the position. So this is the position of the link PQ when it is at extreme forward and when it is at extreme forward. Okay, and when the R block is at extreme backward. So when this is at extreme forward, then block R will be at extreme backward. Okay, so this is the extreme backward position, and similarly this is the extreme forward position. So as this crank is rotating in counterclockwise direction, so uh, this will be the travel from extreme backward position to extreme forward position, and this will be your extreme forward position, so extreme forward position to backward position. So it will be your cutting stroke and it will be your return stroke. As this crank is rotating at constant speed, so time travel to travel this angle will be more, and time travel to this angle will be less. So this will be your cutting stroke and this will be your return stroke. Okay, so quick return ratio will be if we take the quick return ratio as by less than 1, then quick return ratio will be this angle by this angle, beta minus 360 minus beta, so that will be equal to 1 by 2. So beta will be your 120. Okay, or beta by 2 will be your 60 degree. So this angle here 60 degree. So when it is at as this is the uh, circle made by this crank OS, and this is the tangent to the circle, so this angle will be 90. Okay, and this angle is your beta by 2. So this is your right angle triangle, and now this is your 90, this is your beta by 2. So this is your ON. Okay, and this is your OP. So ON by OP will be your, this is your base and this is your hypotenuse. So ON by OP will be your 460 because this angle is 90. So as OP is given, OP is your 500 mm. So we can find out ON. So ON is your 250 mm. So answer to question number 30 is A. So answer to question number 30 is A. Okay. Next, the angular speed of PQ in revolution per second when the block R attains maximum speed during forward stroke. So when block when this block attains maximum speed during forward stroke, then at the extreme backward position, this block will have zero velocity. Okay, at the extreme forward position, this block has zero velocity. At the mid position, it will have the maximum velocity during forward stroke. Okay, so at the mid position, this link PQ will be like this. Okay, and S will reach here. Okay, S will reach here. So this is the position when the block R attains maximum speed. So this is the position of slider S, and this is also the point Q, because Q and S will be coincident. Okay. Now if we assume that link OP, fixed link as link 1, and OS crank as link 2, and S slider as link 3, and QP the connecting rod as link 4, then this will be the common point between link 1 and 4. So OP is link 1 and QP is link 4. So this is the common point between link 1 and 4. So this will be I1 4. Okay, and this is the this is I1 4, and when this is as this is the link 1, and this is your OS is link 2. So as this is the common point between link 1 and 2, so this is your I1 2. Okay, and similarly link link 3 is your S, and link 4 is your QP, and link link OS is your this OQ or OS. So this is the common point between link 2 and 4. So this is also your I2 4. So now we have I1 4, I1 2, I2 4. Okay, now we have to find out the angular velocity of PQ. Okay, so now I2 4 means the point is on link 2 as well as on link 4. So when we assume it on link 2, we'll take the angular velocity of link 2, and we'll take the distance of the point from the center of the from the center point of the link 2 about which it is rotating. So link 2 is rotating about 1 2, and this is the distance between the I24 and I12. Okay, so this will be your velocity of V24 when we assume it as on link 2. Okay, so because I12 means the link 2 will rotate about point I12 when link 1 is fixed. As link 1 is fixed, so it will rotate about this point. Okay, so this is the point of rotation of link 2, and any point on the link 2, to find out its velocity, we will take the distance of that point from the center of rotation and multiply it with angular velocity. Okay, so from this V24 comes out as 2 into 250, so that is 50 mm or 500 mm per second. Similarly, we can assume link 4, sorry, I24 on link 4 also. Okay, so if we assume I24 on link 4, then the point of rotation of link 4 is I24. So we'll take the distance from this point of this point from this point. Okay, and take the angular velocity of link 4. So V24 will be omega 4 I24 I14. Okay, so this will be your 500, and this is your 250. So this will be your 750. Okay, so but this we have found out by assuming it on link 2 is 500. So equating it these two. Okay, so we can find it omega 4. Omega 4 comes out as 2 by 3 revolution per second. So answer is option B. Okay, so here the answer is, so in question number 30 the answer is A.